Welcome back, children. I'm Srinivasan here. We are going to discuss exercise 1.1 relations and functions chapter, question number 8. The question says show that the relation R in the set A is equal to 1, 2, 3, 4 is given by R equal to set of all order pairs where the difference between A minus B is always even. Okay. Now we'll see first part of that question and then we'll go for this. The question seems to be longer, but it's a very simple question. Now let us take the set A equals 1, 2, 3, 4, 5. First, we should understand the meaning of this a minus b. The difference between any two numbers should be an even number. So let us write all the order pairs of the relation R. Do you think the difference between 1 and 2 is even? 1 minus 2 is 1, right? So it is not even. 1 and 3, yes. 1 and 3, the difference is 2. 1 and 3, even 3 and 1. Even if you have minus 2, because of this modulus sign, it changes to positive. It is even. Next, we'll go with the 1 3. We finish 1 4 is odd. 1 5, yes, 1 5. The difference between 1 and 5 is 4. So we can have. Next, I take the number 2. 2 I compare with 3. Its difference is 1. 2 with 4 is I have 2. So 4 comma 2. Next, I get 3. 3 with 4 is 1. So 3 with 2 is 3 with 5 is the difference 2. So 5 comma 3. Do you think any other element the difference is even? Yes, take this elements itself. 1 comma 1 is 0, we take it as even. 2 comma 2, 3 comma 3, 4 comma 4 and 5 comma 5. The difference between them is 0, which is an even number. Now we'll start with the properties. First, reflexive. Let us check reflexive. We know the condition for every A belongs to the set A comma A should be there in R. Then we call as relation R is reflexive. This is the condition to prove reflexive. Okay, children. Now, for every element, you take 1, 1 comma 1 is there. Take 2, 2 comma 2, 3, everything is there. So, we can write 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5 belongs to R. Are there in R. Therefore, R is reflexive. That's all. All this, or individually you can write belongs to R, belongs to R, belongs to R, like that. Or you can generally you can write A comma A belongs to R is reflexive. So I complete that this is R is reflexive. They will accept whatever way you write, they will accept. Next, now we have to show that whether it is symmetric or not. What is the condition for any element A belongs to two elements A comma B belongs to set A comma B should be there in R relation. Then we will prove this implies B comma A also belongs to R. Then we call R as symmetry. 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5 are always symmetric. No doubt about that. Leave that part. Now we'll go for this one. 1 comma 3 is there, 3 comma 1, 1 comma 5, 5 comma 1, 2 comma 4, 4 comma 2, 3 comma 5, 5 comma 3. Is there anything else? Do you feel anything is missing? No, I see all the order pairs are having symmetric with that. So we complete. From this, we have for any A comma B comes in, we can leave like this. This is symmetric. From the ordered pairs in R, we observe that R is symmetric. That's all. You need not want to rewrite it again. Next, transitive. You write the transitive rule. A comma B comma C belongs to A comma B belongs to R, and B comma C belongs to R, which implies A comma C belongs to R. Then R is transitive. For example, you take any example. For example, if you take 1 comma 3 belongs to R, 3 comma 1 belongs to R. I observe that we see that 1 comma 1 is also there, 3 comma 3 is also there. 1 comma 1 also belongs to R, 3 comma 3 also belongs to that. Therefore R is transitive. Like this you can take one example and also you can prove it is transitive. So it is symmetric, it is transitive and is reflexive. So from this, hence R is an equivalence relation. So we have proved that it is an equivalence relation. R is an equivalent. Now let us see. Show that all elements of set 1, 3, 5 and 2, 4 are related to each other. Take the set. Consider set 1, comma 3, comma 5. What is the difference between 1 minus 3? Is even. Correct? 1 minus 3 is 2 or 3 minus 1 is minus 2. When you use modulus, it changes to an even number. Similarly, 1 minus 5 is also even. Okay, whatever element you compare within them, they are the difference between them is even. So they belongs to R. So we conclude that the elements in the set is related to each other. The same is the case with the 2 comma 4. If you say 2 comma 4, the difference between 4 and 2 is 2. So they belong to the so I write consider set 2 comma 4. The difference between 2 comma 4 is even. Therefore the elements are related with each other. Okay children, they are related with each other. Okay, but the next part says but no element of set 135 is related to any element of set 2 comma 5. See the difference between 135 and 24. See the element. What is the difference between 1 minus 2? 1 minus 2 is 1. It is not even. It's not even. Similarly, 3 minus 2 is 1. 5 minus 4 is 1. So, if when you compare these two sets, you don't find anything is even. So, what is your conclusion? No element of set 1, 2, 3, 1, 3, 5 is related to any element of. The reason is the difference between the elements is not even. That I am going to write now. Now, we will write. We observe that between the sets 1 and 2, 4, we observe that between the sets 1 minus 2 is not even, or 1 minus 4 is not even. Likewise, no element with any element, no element of set 135 with any element of set 2, 4. The difference so no element with any element of set is the difference is not even. It's not even. Therefore, the elements of two sets are not related. Or you can take the statement from the question itself. You can take. So we have proved that if we take these two sets, the difference between them is not even. That's why there is no relation between these two sets. But the elements within the set has some relation. 1 3 is even, 3 5 is even. That you should understand. 2 4 is even. Okay, children. This completes the question.